Hello, friends. Today I have come up with another video, and this video is based on principle of conservation of atoms. It's a very close relative to the number of moles because you can easily convert moles into atoms. So for that reason, you need to first convert moles into number of molecules, and after that, you need to multiply with the atomicity. So let's try to understand how it can be done with various example. Let's take one example. So, in this particular question, it is said that an impure sample of KClO3 weighing 1.5 gram is heated strongly to yield KCl and oxygen gas. If the reaction produces 0.149 gram of KCl, what is the percentage purity of the original KClO3 sample? How to do this? Let's first write down equation. Now, after writing down the equation, what you need to understand, total number of atoms of potassium present in the left hand side is must be equal to the number of potassium atoms in the right hand side. So I am just applying principle of atom conservation. By applying this principle on atom potassium, what we are going to see, atoms of potassium. So atoms of potassium can be written as 1 into number of moles of KCl. So whatever atoms of potassium is present in KCl must be equal to the number of potassium atoms present in KClO3. That is, I have written in the left hand side. You can see this. I have written this in the left hand side, and this one I have written in the right hand side. Now, when my this equation is set, after that I'll just convert amount of KClO3 into moles and amount of KCl into moles. So already it is given amount of KClO3 is 1.5 gram divided by molecular mass 122.5 is equal to the number of moles of KCl. Now remember, the amount that is 0.149 gram of KCl given, it is not actually theoretical amount of KCl obtained from this KClO3. That is practically obtained. And remember, this KClO3 has some impurity in it. So that's why this 0.149, it is not an theoretical value. So now here I'm going to calculate the theoretical value, and let's consider the theoretical value is x gram, and molar mass of KCl is 74.5 gram. So therefore x is coming out to be, so if KClO3 was 100% pure, then amount of KCl should be obtained is 0.912 gram. But in reality, the amount obtained is much lesser than that. Now our job is to find out the percentage of purity. So there is a little space left, so I'm just calculating that. So percentage of purity is equal to experimental mass 0.149. So answer is 16.33%. Now, before going to the another sum, just let's explain it once more. See how I am reaching to the number of atoms of potassium, both from KClO3 and KCl. It is because of this flow chart, because how I'm going, I am first taking this route, where the this is the given mass. Here you can see this given mass. Let me write it with a different ink. This is the given mass, okay, in both the cases. Now there I am dividing by atomic mass, molecular mass. See, this is the molecular mass. I am dividing molecular mass. I am reaching to the number of moles. And after that, I am multiplying atomicity. Here is the atomicity. You can see this atomicity here. It is 1. Here also 1. If I don't multiply, it doesn't matter. But if there is uh, different number of atoms, then definitely it will matter. So in that case, we are able to find out this particular theoretical value of KCl that should have been prepared. So by that method, we have easily calculated percentage purity. Okay. Now let's go to the another sum. So if you can read this question, it is found uh, sequential equations in a series of reactions. All the carbon atoms from K2CO3 is converted entirely into the complex. This very big complex. What mass of the final complex can be produced starting from this gram of K2CO3? So now again, applying principle of conservation of atoms on carbon. So if we apply this principle of conservation of atoms of carbon here, then we can easily calculate that. So let's apply principle of conservation of atom on carbon. Okay. So what we'll find, 1 into moles of K2CO3, okay, is equal to, now you need to understand how many atoms of carbon is there. Here you can see the 6, and outside another 2 number is there. It means 12. So is equal to 12 into moles of this big compound. Big compound. Okay. I'm not writing full things. There is no need. So now next thing, what I need to do, I need to write 1 into given mass, that is 27.6 gram. I'm writing it down. 27.6 gram, and and divided by the molecular mass of KClO3, that is K2CO3, that is 138 gram. Okay. So how I have got this number of moles? Definitely from this point to this point I have reached here. Okay. Now is equal to, just using yellow ink because it is more visible, 12 into, now what amount of this big compound will be produced? Let suppose this is X and the molecular mass is 698. Now you solve it and get the value of X, and that is the answer. 11.63 gram. I hope you people are understanding how this principle of conservation of atoms are applied here. So now let's take another example. So this question is basically, they are asking to calculate molecular formula of the hydrocarbon, and they have given various gaseous substance involving in the reaction. So it's a kind of Eudiometry along with the POC principle we need to apply. So let's see how to do this. First, we'll write down the equation. Now let's try to understand what sort of data they have given. They said the 10 ml you have taken of the hydrocarbon sample, and it was burned completely in 80 ml of O2. 80 ml of O2 doesn't mean that all the oxygen gas is being utilized. So, but you are giving 80 ml in excess. You need to understand that. It's all are not participating. Okay. Okay. Then remaining gas occupied 70 ml at NTP. When they are saying NTP, it means normal temperature and pressure. It means the volume of water will be negligible. Okay. It will convert into liquid, so it will be negligible. So whatever gas left behind, they are saying it is 70 ml. So we can understand it is the leftover oxygen and CO2 gas combining together is 70 ml. Okay. Acha. Now they're saying out of this 50 ml, this volume becomes 50 ml on treatment with KOH. It means 20 ml gone. 20 ml, how it is gone? When you are reacting with KOH. And you know, CO2 being acidic in nature, it reacts with the KOH. So the total volume that is 20 ml has gone. It can be understood. It is nothing but due to the CO2 gas. So volume of the CO2 gas must be 20 ml. So when 20 ml is gone from the 70 ml, whatever 50 ml is left, it is nothing but oxygen gas. So leftover oxygen gas is 50 ml. So how much amount of oxygen is actually utilized? So now we need to understand actually utilized oxygen is minus 50 leftover oxygen gas. So it is nothing but 30 ml. So now we understand that 10 ml of this hydrocarbon reacts with 30 ml of oxygen completely, produces 20 ml of CO2 gas, but we don't know anything about water. Now our job is to find out what is X and what is Y. So now I'll be applying principle conservation of atom on carbon. Okay. Principle of conservation of atom on carbon. If we apply, then what we'll find X into, this is the atomicity, moles of CXHY. In that case, we can write 10 divided by 22.4 liter. Since it is in ml, 22400 it will be. Although later on you will find there is no point of writing this. I'll just showing it because it's the first time you're doing. So that is the moles of carbon on the left hand side. On the other hand, in CO2, 1 into moles of CO2. That is 20 divided by 22400. Now you can see very carefully in both the side 22400 coming below. So they are cancelled out. So there is no need or requirement actually. So we can write as x into 10 is equal to 1 into 20. So therefore x is equal to 2. So we understand that x is 2. Now I need to apply principle conservation of atom on hydrogen. And then let's try to do this. For that reason, I need to go to the different, I need to erase it. I cannot go to a different page. Now applying principle of conservation of atom on hydrogen, it will be y into 10. Now I am not dividing by 22400 because you are knowing that if you divide it, then you need to divide in the other side also, and they will automatically they will cancel out each other. So this is equal to the 2 into moles of water. Okay. Now we don't know moles of water as well as don't know why. So from this equation, you cannot calculate that. Now we'll be applying principle of conservation of oxygen atoms. Then applying on oxygen atom, it will be 2 into 30 for oxygen. Here, this is the 30 value. Okay. Is equal to the 2 into volume of CO2. You can see atomicity of oxygen is 2. So I have written it down. Plus 1 into moles of water. Now you can see this moles of water is coming out to be. So now you can see this moles of water is coming out to be 20 ml. Now this 20 ml I'll be using in this equation equation 1. So how it will come out to be? Let's erase something. So now y into 10 is equal to 2 into 20. Therefore, y is equal to 4. Therefore, molecular formula is C2H42. That is the answer. So, we have solved three very interesting numericals based on principle of conservation of atoms, and I hope you people have understood. And if you need, then I can solve even more sums. So please drop your message in your comment box. Okay, and I'll go through it, and then I'll make another video if there is requirement. So till then, bye bye. Take care.